Hello and welcome to the Ways of Math. I'm your host, Dan the Math Man, and today we're going to bring you yet another video on this Introduction to Basic Probability series. Before we continue, please be sure to subscribe to the channel so that you can be notified of future videos. And as always, if you have any comments or suggestions on the video, please leave them in the comment box below. Today is part 3 of our series on Introduction to Basic Probability, and we're going to be talking about odds today. So, in this video, we're going to talk about what are odds, what are they, what do they mean. We're going to talk about the definition of odds, the relationship between odds and probability, they are directly related, how to determine probability if you're given odds, and of course we're always going to show examples on how to compute things. So what are odds? You've probably heard the words the odds are. We hear these words often when referencing things like the odds of winning the lottery, or the odds of experiencing a car crash, or the odds of being successful. But what are they? What do they really mean? Odds are a numerical expression that relate the likelihood of opposing outcomes. Sound familiar? I hope so. It's almost like a probability. However, while a probability computes the likelihood of an individual outcome or specific type of outcome, odds compute the relationship between success and failure. So, because we're relating success and failure, these are two polar opposites, this yields two types of odds. The odds for, or otherwise known as the odds of, and the odds against. Now, in general, when we use the term odds, it usually references the odds against, right? So, if we talk about the odds of winning the lottery, we're actually talking about the odds against winning the lottery, or the odds of being successful in life. It's really the odds against being successful, right? And so that's what we're usually talking about in general cases. But of course, context matters. So as with probability, you want to make sure that you're clear on specifically what type of odds you're talking about, and not just assume. Okay, so the definition of odds against. Okay, so this is the following formula that we use to compute the probability, or the odds of, against an event. So the odds against an event is defined as being the probability of failure divided by the probability of success. Now, for those of you who are familiar with kind of set theory and set notation, or possibly watched my other series on the introduction to sets, you can also think of this and express this as the odds against an event E by being the probability of the complement of E divided by the probability of E. Notice that odds are the ratio of the probability complement of an event to the probability of the event. So consider the following example. Suppose we have a well-shuffled standard deck of cards. This is your standard 52-card deck. Now, suppose we want to determine the odds against drawing a face card. Well, recall in a standard deck there are 12 face cards. 4 kings, 4 queens, and 4 jacks. 12 total. Therefore, the probability of drawing a face card is 12 out of 52. 52 possible, 12 of which are favorable. And simplifying, this gives us 3 over 13. Now, using the probability complement, the probability of not drawing a face card is 1 minus the probability of drawing a face card, which is 3 over 13. And that simplifies to 10 over 13. Therefore, the odds, by using the previously mentioned formula, against drawing a face card is the probability of not drawing a face card, which is 10 over 13, divided by the probability of drawing a face card, 3 over 13. Doing a little bit of arithmetic, the 13s cancel here, and we get 10 over 3. In the context of odds, this ratio, 10 over 3, is usually written like this, with a semicolon, 10, semicolon, 3. And we read this statement as 10 to 3. Thus, the odds against drawing a face card are 10 to 3. Now let's consider the odds in favor of the event. So the odds in favor of an event are the probability of success divided by the probability of failure. And again, for those of you familiar with sets, we can express the exact same formula as the odds in favor of E being the probability of the event E divided by the probability of the event complement. We see here that the odds for an event is precisely the reciprocal of the odds against an event. This is kind of nice. It makes working with odds convenient, especially if we're wanting to know what are the odds for and the odds against. They're simply reciprocal of each other. Okay, let's consider an example of finding the odds for. So suppose we roll a fair six-sided die. Determine the odds of rolling a number greater than 4. Okay, so since there are two numbers greater than 4 on a six-sided die, that is the numbers 5 and 6, the probability of rolling a number greater than 4, the number of favorable, 2, divided by the number of possible, 6, reduces to 1/3. Now, using the probability complement, the probability of not rolling a number greater than 4 is 1 minus the probability of rolling a number greater than 4, 1 minus 1/3, and that simplifies to 2/3. Therefore, the odds of rolling a number greater than 4 is the probability of success, 1/3, divided by the probability of failure, 2/3, and with arithmetic we get 1/2. And again, we write this as a ratio. The odds of rolling a number greater than 4 are 1 to 2. Okay, so we've seen that odds are obtained from probabilities, but we still haven't really gotten to the core of what odds really mean, right? And specifically, what do they mean in the scope of probability? Well, notice in each instance of computing odds, the denominator of each probability, that is the number of possible outcomes, is canceled in the division process. Well, this really leaves us with the ratio of the number of successes and the number of failures related in our ratio. In the case of odds against, the ratio is the number of expected failures, remember that we're dealing with expectation with probability, to the number of expected successes. As an example, the odds against ratio of 3 to 2 means that we expect a ratio of 3 failures for every 2 successes. Again, remember that in probability we always rely on the law of large numbers. This doesn't mean that if you have 5 trials, you're going to expect 3 failures and expect 2 successes, right? But we expect in the long term to have the ratio of approximately every time we have 2 successes, we're also going to have 3 failures. Similarly, on odds of ratio, on odds of a ratio, okay, so odds for being 3 to 1 means that we expect 3 successes for every 1 failure. Okay, and again, remember that we're talking about the number of expected successes versus the number of expected failures. Okay. Now, this kind of gives us a deeper understanding for odds, and we can actually kind of think of it in a different way. So, because again, the number of the possible outcomes is going to be canceled by the division, we can express equivalently odds against an event as being the number of expected failures divided by the number of expected successes. And similarly, the reciprocal, odds in favor of an event, is the number of expected successes divided by the number of expected failures. Thinking of odds in this way gives us kind of a relatively direct way of computing the probability of an event. So suppose you know the odds and you want to compute the probability of it. We can compute the probability and the probability complement given that we know the odds from understanding odds in this way. So recall that in any experiment, either an event happens or it doesn't happen, right? So therefore, we can infer from this that the number of successes plus the number of failures must be equal to the total number of possibilities, right? We can't have some extra things where it's neither successful nor is it a failure. It doesn't work that way. It doesn't make any sense. So if we're given odds, either for or against, we can interpret the number of successful outcomes and the number of not successful outcomes, which we call failure. And from there, we can interpret or compute the number of possible outcomes. Next slide is going to show a formula or a process for how to determine probability given odds. Suppose we have an event E, and we're given that the odds for or the odds against E. Then, first step is to determine the number of successes of E and the number of failures. For notational sake, we're going to call them successes S and the number of failures F. If the odds are given as the odds against, then that means we have the ratio of F to S, failures to successes. If we're given the odds for, then that means we have the ratio of S to F, successes to failures. Then we can compute the number of possibilities, we'll call that P, by adding up the number of successes and the number of failures. So P is S plus F. From this information, we can now use the definition of probability. The probability of the event E, P of E, is then the number of successes, S, divided by the number of possibilities, P. And the complement, probability complement, is the number of failures, F, divided by the number of possibles, P. Okay, let's see how this is used in an example. So suppose you're applying for your first job after graduation, and you know the odds of being hired on your first attempt are 3 to 8. Determine the probability that you get hired, and determine the probability that you don't get hired. Again, this is just on your first attempt, the first job you apply to. In the problem, we are given the odds for the event that you get hired on the first job that you apply for. So the odds of being hired are the number of successes, expected successes, divided by the number of expected failures, 3 to 8. Therefore, we can imply that S, the number of successes, is 3, and F, the number of failures, is 8. We can now compute the number of possible outcomes P by adding S plus F, or 3 plus 8, which is 11. Therefore, the number of possible outcomes is 11. We can now compute the probability of being hired by using the definition of probability, which is the number of expected successes divided by the number of possible outcomes, which is 3/11. Now, since we've already computed the number of possible outcomes, and we already know the number of not successful outcomes, or the number of expected failures, that is, then we can compute the probability of not being hired as being F divided by P, or rather 8/11. Now, of course, we can always use the probability complement, because remember that the probability of an event and the probability of the complement of the event are related. So we can also compute the probability of not being hired in your first attempt as being 1 minus the probability that you are hired on the first attempt, which is 1 minus 3/11, which is 8/11. However, in this case, since we knew S, F, and P, it was easy just to compute it directly. Okay, so let's summarize what we did in this video. Odds use probability to determine the number of expected successes to the number of expected failures, or vice versa, depending on which odds you're looking for. The definition of odds against an event E is the probability of failure divided by the probability of success. Remember, we can also think of this as the number of expected failures divided by the number of expected successes. We can compute the odds in favor of an event, E, by the probability of success divided by the probability of failure. Again, we can also think of this in terms of the cardinalities, or the numbers of these. So the number of successes, expected successes, divided by the number of expected failures. As we see here, odds for and odds against are reciprocals of each other. If we want to determine a probability from an odd, we first determine the number of successful outcomes, the number of not successful outcomes, otherwise known as failures, and we use these to compute the number of possible outcomes. With all this information, we can then compute the probability using the appropriate probability definition. I hope you enjoyed this video on odds. Thanks for watching. As always, please be sure to subscribe, and please leave any comments or suggestions in the comments below. I hope you have a wonderful math-filled day. Thank you.